Exploited, the Cyber Truth, a podcast by RunSafe Security.
Welcome back, everybody, to Exploited, the Cyber Truth. I am Paul Ducklin, joined as usual by Joe Saunders, CEO and founder of RunSafe Security. Hello, Joe.
Greetings, Paul. Great to be here.
And our special guest for this episode is Jacob Beningo, CEO of Beningo Embedded Group. Thanks for coming on board here, Jacob.
Yeah, thanks for the invitation.
Well, we have a very exciting and I would like to say important topic to talk about, which is, if you like, one of the elephants in the room in all sorts of software development, but particularly in embedded security. And our title for this episode is AI wrote the code, but who bears the risk? And as intriguing as that question is, Jacob, maybe because of your background in embedded programming and the fact that you're deeply involved with the Zephyr RTOS, real-time operating system, maybe we can open up by you just explaining to our listeners the difference between the real-time in real-time operating system and what a lot of people think of as real time, which just means, hey, I recorded a video and it played back in real time. I didn't have to wait for it to be processed. Or I had a Teams call and there was no lag. It's a very different sort of real in real-time operating system, isn't it?
Well, it definitely is. Yeah, when we think about real-time embedded systems, this is where you're thinking about bounded response times. So you want something that when you press your brake pedal in your car, for example, you want that brake. You want that
stutter and go, hold on, buffering.
Exactly. You want it to respond within, let's say, 10 milliseconds of a press, right? And so the real time there's bounded responses. It's deterministic. There's guarantees about how quickly it will respond back to you. And so, in the old days on a vehicle, you'd press your brake pedal, right? And it was connected to mechanical pieces. Today, there's software in between. So there's no physical connection between, for example, your brake and the actual brake pads on your vehicle. So when we think about real time, this is where we have systems that, they could be safety critical systems. They could just be normal devices, but they have bounded response times. They have bounded periods of times where things have to happen. Otherwise, you find either a degradation in the way that the system behaves. Like if you were to push a touch screen and nothing happens, or you get a delay, let's say for 2 seconds, and then suddenly, you move to the next menu, you get a decrease in the value of the actual product. Or in worst cases, like in a safety
cause
system,
problems, can't it? Because people might press 2 or 3 times and they might inadvertently approve a transaction they didn't intend to.
Exactly. You press it.
But that's very different from pressing a brake pedal,
now it's
sailing through a red light,
yes,
and then having the brakes slam on when you're on the other side of the intersection.
Exactly. So you can see there's variations in degrees to real time based on the type of system you're developing, right?
Yes.
From consumer electronics through medical, transportation type systems and so on. So, but generally we look at it as that bounded context, that determinism of basically time guarantees that the operating system will, and even your code, because the RTOS itself, even though it's real time, it's up to us as a developer to make sure that we're paying attention to those times and those responses. And that we don't, break something on the RTOS itself. But
so it's not necessarily about being fast. You could have a response time that's allowed to be 10 seconds, but not 10.001 seconds. And that's still critical, isn't it? It's not like, 1 second is great, and if every now and then it's 11 seconds, the average will be okay. There are hard limits, and and like you say, it's all about the determinism rather than being mostly good enough.
Exactly. Oftentimes when we develop requirements for an embedded system, we talk about soft requirements and hard requirements. And those are soft real time where the deadline's kind of loose. If you miss it, no big deal. Then there's the hard real time, which is, if you miss that deadline, well, system degrades or bad things could happen to the user potentially, right? So.
And part of the compliance that you would have to go through and part of the verification for your software to be accepted will be to show that A, in testing, you do meet those real-time requirements, and B, that the system has been built in a way that is likely to be the case indefinitely.
Yeah, absolutely.
So When AI starts generating code that goes into firmware, how do things change?
Oh, I would say everything changes. So, just
Now,
from
change
the
is not
way,
necessarily bad. It's the
no,
unpredictable side effects of change that are the problem.
exactly. It's the unintended consequences. It's the changes to processes. It's the changes to the way that we think about developing the systems in general. Even the fact that you don't want to become complacent with the way that you're developing that system. There's all kinds of things that change from education and so on and so forth. So, uh,
So, do you think that there's a risk, if other than the mere fact that AI is known to make mistakes, sometimes egregious ones that are non-obvious, do you think there's also a risk that the fact that instead of having to sit down and think carefully about code and then work on it and maybe get your peers to review it, that you just throw it at some statistical inferencing engine and back comes something that looks great? Do you think there's a, if you like, a psychological or a social risk, if you like, that breeds overconfidence?
think that it can breed overconfidence if you're not careful. If you're thinking about the tool as something that I ask for a solution and it gives it to me, and that's the end of the day, right? But if you think of it as instead a tool, an extension, and you think of the fact that it's not necessarily better at doing it than you are, right? It's actually a tool that can help you accelerate what you're doing, but at the same time, it's going to make mistakes just like anybody else. I've made some fantastic coding errors in my days of programming. When we say, "Oh, the AI hallucinated or it, generated some bad output," I kind of say, "Well, I'm just as guilty myself." And so, how do I prevent myself from making those same mistakes? Well,
Yes.
I put the right processes in place, right? I use the right tools, and we go through a rigorous process to make sure that the output is what we actually expect it to be, and that it
Who
does what it should.
hasn't coded a condition the wrong way round by mistake? Perhaps
Exactly.
because somebody else chose a weird variable name, like disable this feature equals true, which
Yes.
is bound to lead to semantic confusion later. Now, an AI can't step beyond those sort of mistakes if it's basing its code on stuff that you've pointed it at that already contain those mistakes.
Yep. Exactly. And that to some degree is where some things I think actually change because you kind of go in using these tools thinking, oh, well, it should be perfect, right? But what we've trained a lot of these code generators on is open source code that may be high quality. I don't want to say open source is bad. There's a lot of libraries that I use that are actually really good. But there's also a lot of maybe lesser quality code bases out there that I'm sure we're still fed to AI, right? You didn't have really high quality, I'll say confidential code that was provided to the AIs to generate really high quality, outputs. And so we kind of have this engineering 101 problem of, garbage in, garbage out, right? And I don't want, again, we haven't given it all garbage in, but you have to kind of tailor also your own requirements and inputs to it so that you actually generate the expected outputs from these tools.
Because I guess in the old days, by which I mean 5 or more years ago, I suppose, the general advice was you can go online and get code without writing it yourself just by going to Stack Overflow or some site or code project or something like that. You can copy and paste code, but that just means you've copied something. You copied may not what you've copied may not be any good and may actually have been sitting around and maybe followed, if you dug down a bit, by comments saying, no, 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 this is a fantastic example of what not to do. And so we sort of all learned that. We programmers learned that lesson of not being overconfident in code they'd copied and pasted. But with AI, things are in presentation terms a little bit different, aren't they? Because the code often looks as though it was created from scratch. It doesn't have all the comments left in saying, I wasn't quite sure about this, you need to check it. Those will have gone. So the code could, if you don't know what you're looking at, perhaps lead you to a false sense of security or make it look as though it needs review and testing and vulnerability assessment to a lesser degree than it really does. Would you agree with that?
Oh, absolutely. You can get some code that looks fantastically polished out of it. And you glance at it and you start doing a review and your mind
Yeah.
goes, "Oh, this looks great. Like I don't see any problems with this." Which is, why I think when you do use AI tools, you really need to have a good checklist, a code review checklist, just like we do with our peer reviews, right? You go through and you check it for, you can check it for style guides, although you can train AIs to do that as well. But we look for vulnerabilities, run your stack analysis tools, run it on your intended target, and actually do dynamic analysis on it as well, pen testing, all of those types of things that, we should be doing anyways. We should also be making sure that we do that with our AI generated code as well. And I think if you do that, it helps move you from where, first of all, you shouldn't trust what it outputs. You should really be questionable and be like, okay, yeah, this looks okay, but let's really beat it up and prove that it works. Make sure that I don't want to pick necessarily on your entry level engineers, but they're generally inexperienced. And so you have them write code. And what do? You beat them up and kind of teach them through experience that, okay, well, this isn't maybe the best way to do something, right? I kind of think we go through that same process with the AI tools, right? So treat them with, respect, I guess, but expect them to, produce faulty outputs.
I guess this is not a new problem, is it? If you go back 30 or 40 or even 50 years in programming, when all you could really do was either get the manufacturer's programming guide in a great big ring bound document, or you could get the textbook that was the flavor of the month or year at big universities, and you could look at code in there. But then, firstly, you had to type it back in yourself. You couldn't copy and paste it. So you could introduce errors by mistake, or that code might not have been correct. If it was in a book that was published 5 years ago, ideas might have changed, better techniques might have come about, and improved algorithms even. So there might be nothing wrong with the code from a vulnerability point of view, but when it comes to something like real-time performance predictability or determinism, it might not quite live up to its reputation. And that's a very, very specific human skill, isn't it? To be able to write code where you can say, I know this will respond within time, and I can either show that reliably or even perhaps come up with some kind of formal mathematical proof that the code will be correct.
Oh, absolutely. Yep. Yeah. Well, go ahead.
No, gone.
Oh, I was just gonna say I've seen examples like in the field where you know I would go and you would review. I've actually done the experiment where we had entry level engineers. They wrote some code for a system, and the system, as it turned out, was not, let's say, running it to the real time level that it should. Okay, let's say it was using like 85% of the CPU. There was, as most modules, there's a little small portion of the code that they wrote that was really kind of using up a lot of the real time performance of the system. And then what we ended up doing is we took an AI and kind of had it run through the code and try to have it improve the performance. And it actually took it from about 85% CPU utilization down to about, I'll say it was like 52%. Drastic improvement. And then we took a senior level engineer like myself to come in and rewrite that code. And we got it down to like 40%. Right. So, that kind of gives you a little bit of a feel from a real time perspective of, where these tools currently are at. Right. AI doesn't really understand fully how to fully optimize, for the in targets. It just doesn't have that experience. It's mostly trained on, again, code that's open source and that, maybe it's C language being used for, maybe some other type of application on a desktop, or C++ for data science or something where they're not as concerned with
Yeah.
efficiency and performance.
Yes, where having a mere 16 gigabytes of memory is, well, that's just what you have on your beach laptop. Although, 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 having said that, if you look at the price of RAM these days,
Yes,
if you've got 16 gig, keep it,
yeah,
or sell half of it, because you can probably make some money if you can live with 8 gig.
exactly.
And that seems to be down to the need that AI has for consuming memory, and that's it. If you like, whatever is the opposite of a luxury, that's something that you absolutely don't have in the embedded world, do you? You have a certain amount of memory. It comes with, say, the system on chip, and that's that. You buy
Yes.
that device, you program that device. It's not that you go, well, if we can always add a bit more memory. It's the device is quite constrained on purpose, because I guess that also helps it control how much power it uses, and if you like the real time, the long term real time performance, where you can say this will run for 3 weeks on the battery that we provided, and we can be absolutely certain of that we're not going to suddenly have somebody playing a game or turning up the video resolution in a way that causes the battery to run out faster. So how do you
Exactly.
look for mistakes like that in AI generated code? Because certainly as a writer, I noticed that a lot of what the AI writing bots do is they often write rather nice prose, but you often get the sense that it's kind of trying to say what you want to hear in a way that is polite and therefore leads you to think it must be nice and decent, even if, with the best will in the world, it's told you the opposite of what is true because it just started from a false premise. So how do you deal with what you might call the devil in the details with AI generated code, particularly when it comes to the in real time operating systems, things like memory consumption, power usage, response time, determinism, inability, protection against things like deadlock or the system locking up and not being able to recover? What do you look for, and how do you go about using AI to your advantage while managing that risk?
Yeah, so I think there's a lot of stuff that we can unwrap there for sure. So when we think about applying like AI in embedded systems, or we'll start with the first part that you mentioned there, which was how do we recognize and look at the code and kind of make sure that it's meeting what we want it to do. And one of the things that I have done in my development is I don't allow AI to just run off and do a whole bunch of stuff at once. You'll find that a lot of tools out there, they're very much trying to push agentic workflows where you tell it a little bit of
Yes.
information and it just runs and just goes. I'd very much constrain it to, I want to do this one little thing and just let it generate a little bit of code. And then I review that code. I look to see, what are the inputs, what are the outputs? Is it checking the inputs? Is it checking the outputs? Do those outputs make sense? I'll use it to potentially generate test cases for the code that I'm writing. I like to use test-driven development where we write the test first, watch the test fail, write some code, production code to make it pass, and then we refactor after that, right? But what I do is I take it very, very piecemeal, and so that it's almost like I'm writing the code, but I'm almost pair programming with the AI, because then I can see I keep it in my editor, I see what it just generated, I look at it, I go,
Yeah.
well, I do it like this, and I could go in and make the changes myself, or if I'm being lazy or interested to see what the tool does, I might tell it, hey, well, I don't like this, make this change, right? Because some of this today is not just letting the AI write the code for us. It's understanding the tools, its capabilities. If I tell it this, what does it do? If I give it these inputs, how does that change the outputs? And trying to get a kind of a constraint around how do we actually use this? Where is this stuff actually going in the future? And so I really limit the amount of stuff that I do with it for code generation. Now, when we look outside
So
of
you
code,
use it as a tool, not as a magic wand, basically.
exactly, yeah, it's not we're not vibe coding and saying, build me a weather
Yeah.
station or build me a brake controller and just let it go and chug away for 2 hours and come back. I
Do you
recently,
think that the media are making things a bit more dangerous than perhaps they need to be with AI by talking up some of the stories that you've seen lately? Like, hey, this guy told AI to write a whole browser from scratch and in a week it had one. Or, hey, these guys spent $20,000 of credits and they got a very low quality C compiler, like the whole
yeah,
project. Now,
yeah,
my understanding is that the researchers who were doing that, they weren't trying to build a browser or build a C compiler. If you want a C compiler, go and download one that's known good, and don't try and knit your own out of rotten string. The idea was to see what happens if you let a whole load of agents work together, just to judge what the effect would be. So they weren't planning on writing a great compiler, they just wanted to see what happened.
yeah.
But
Could it
those
get to the
stories
end?
have sort of been pitched as, hey, you just say, like you just said, write me a brake controller for front disc brakes on a vehicle of this mass. Click. That's never going to work, is it?
No, it really isn't. So there's a whole bunch of process that needs to go into it. I recently put together a simple push button example. I call it a universal push button. Everybody in embedded systems at some point, they have some, a button that needs to be read. And all it does is it debounces the switch and it tells you, is it pressed? Is it not pressed? Did someone double press it? That kind of thing. And I allowed AI to generate that code, but I didn't tell it, build me a universal GPIO controller. What I first did was say, hey, let's generate some use cases around a push button. I gave it an example of what, here's a product description, a page long product description of a push button module and what it should do. And then I said, build me some use cases, user stories around this. And it generated like 10. And then I go into the use cases or the user stories and I look at them. I say, oh, well, this one's kind of off. No, I don't like this. Let's delete this one. Let's add this one. And I end up with good user stories. Then I tell it, let's build requirements from that. And it generates requirements. And then you go in and you look at those requirements, you remove some, you edit them, again, kind of following a process to where you have real requirements. And then you say, okay, off of this, let's try to draw a software architecture, right? And it draws something that's horrible and you go and you fix the architecture. And so what you're doing is you're following your normal development workflow, but you're using AI to help accelerate pieces of it. A lot of times, as an example, embedded developers start projects without a full set of requirements or use cases. They get a little description and AI becomes a tool that you can say, well, fill in the blanks and give me an idea of what's here. And then if you take that, you might end up with a bunch of user stories that you could then go to your customer and say, hey, is this what you want built? And they might say, no, I don't want this and this and that. Okay, cool. And then you can, again, generate requirements, create an architecture. And then you might say, okay, well, and this is just a single module. So you might say, okay, well, now that I have user stories or requirements, I have an architecture, go ahead and build that for me. Okay. And then you feed it what processes you want to follow and that sort of thing. I actually had a really interesting experience when I did this because I had a test-driven development agent I had created. And the idea is that you would tell it to, you tell AI to follow test-driven development, use the TDD agent, again, write a test, watch it fail, write the production code for it, watch it pass, then move on to the next one. Okay. And I told it to go write the code. And after about, I'll say 30 seconds, it had finished writing all the code, all the tests, everything. And I was like, oh my gosh, like that was extraordinarily fast. And then I noticed the output of the AI was, would you like to run the tests? And I was like, well, that's interesting. And I said, didn't you already run those tests and follow TDD? And it responded back, no, that would take too long.
Yes. So I guess what that means is that given that the AI does not have and is not supposed to have this type of reasoning and intent that human creator would, you have to take that into account in how you build AI into your workflow. It's part of the workflow. It may be a partner, it may be a productive partner, but you're not saying go and interactively make all the decisions for me all the way along and, wake me up when we reach the destination.
Exactly. You're not doing that. You're using it as part of your normal workflow to accelerate it, to do parallel processing for you. Like while maybe it's doing a little bit of, maybe while I'm writing code, I'll have it off doing some research, looking through a 3,000 page data sheet, or, hey, we have this problem, go search the web and find potential solutions for this. Or, there's a way to multitask in a way that we maybe weren't able to before, or a way to process data even in a way that we haven't been able to before. And so I really see this as a tool to help you accelerate. It's not the magic wand that you see in the media where they're really trying to, push it as you just say, hey, make this thing happen. And it runs off and, with a team of 30 other agents, solves the problem for you. This is really a tool, I think, that helps us automate away the things that we do on a day-to-day basis that get in the way of us actually being creative, of us actually solving the problems that we should be solving. And that's, I think, where the real power is there. So,
I think another example along these lines gets to fixing either vulnerabilities or bugs and things like that. And in the exact same way, prompting specific tasks or asking, or prompting the AI engine to maybe resolve a certain vulnerability and see what it comes up with, but not necessarily then offer, here's my list of vulnerabilities, please, so go fix everything for me. But if you do it in a prompted way, one by one, and you can review those and and maybe fine tune some of them as you go, then not only are you more efficient in fixing your vulnerabilities, but you also are then including that same level of control that Jacob's advocating around prompting, earlier in the process when you're developing new features or testing out concepts or, implementing the next step. And I do think part of the opportunity here, though, is to know when AI is being used and when it's not being used. And I think that kind of metadata at some point is going to be useful down the road. And wouldn't we all love to know if a component was written by AI or not? If we're looking to assess even an open source component, whether it's trustworthy or not. And so in any event, I do think it's changing workflows. And in the embedded software world, especially where there are mission critical systems, let's think about aviation or autonomous driving, or even industrial controls and industrial automation where there's blades and other things in facilities, there is a significant consequence if something goes wrong. So I think elevating your productivity is, of course, great and welcome, and maintaining that level of discipline and control and checks and balances in the development process is also absolutely essential for any of this to make sense in the first place.
Absolutely.
Joe, you raised us what I think of as a vital background issue there about not just about the correctness of the code and its real-time performance and the accountability you have to what the code does, but also the accountability that you have, particularly if you're using open source software, for correctly licensing the code. And that is one of the many elephants in the room these days, isn't it? That if you have code that came from an open source project, quite clearly labeled, quite clearly licensed, but someone along the way, perhaps not with evil intent or perhaps not trying to violate any legal norms, but just because they thought it might be a good idea at the time, could, if you like, permute that code, deliver something very similar, but it won't show up in your software bill of materials as exactly the version it would have if you'd picked the standard version. And therefore, if the standard version has a vulnerability, you might not realize that this machine rewritten version also has that vulnerability, but kind of invisibly. Do you think that's a problem waiting to happen, or is it something that we're seeing already?
I think it is. I think it does happen. I think, if you rely on SBOMs to identify maybe the CPE or the PURL associated with the component, and that no longer gets identified, then you can't link to the vulnerabilities. And so I do think that's one example then of how, some of this metadata about when AI is used could be useful. But I would like to show a positive view on, or an optimistic view on this. And as a quick story, I used to play for 25 years, I played in this Thanksgiving Day turkey bowl among friends and family and neighborhood football game. And it used to be that the rules were the kids, in a
very pleasant way.
They used to be that the rules, the little kids always had to touch the ball once per possession. Otherwise, the adults would just dominate the game. And as the kids got older and became teenagers and high school football players, and the older parents got older and started to slow down a bit, the rule flipped. And it became that the parents had to touch the ball once per possession. And my point is, in this world where we are relying on AI to help, build certain components or solve certain vulnerabilities or fix a bug or what have you, I do think there is a need, Paul, to your point, that we do need to, kind of assess trustworthiness of components. And I would venture to say that even to what Jacob alluded to earlier, he has made mistakes in his day, maybe one or two.
Daily.
But I think over time, we're going to find that AI-generated code could be more trustworthy than human-generated code. And so that is some distant out in the future. There's too many smart people that know how to build code. And to Jacob's point, the engines haven't quite caught up to know which one is great quality code and which one isn't, although we're making strides there. But I would venture to say at some point, we're going to trust AI code, just as we realize that those young kids grew up and became great football players and and the parents became outdated.
Exactly.
Yes, from a hobby project that I work on myself in my free time, I had a similar experience, not with AI, but with something that used to be looked down upon in the bad old days, namely compiler optimization. And the warnings have always been, well, when you turn on minus big O3, that the super duper optimization in GCC or Clang, we don't promise it will generate correct code, but it will be quick. So I thought, well, I'll go down the middle. And I was trying to speed up some cryptographic functionality that I needed by writing hand assembler code of my own. It was for some testing purposes. And try as I might, I could not beat Clang's optimizer. I could equal it after I'd studied its output and seen the little tricks it had used. And that was before I said, well, let's put it through an optimizer that takes into account the exact CPU I'm using by maybe changing the order of instructions a little bit. And yet, when I started programming, optimizers were considered a sort of unnecessary evil. You kind of use them if you were no good, but if you were really hardcore, you would go and write the assembler code yourself. Now, although I pride myself on being able to write good assembly, I couldn't beat the optimizer. It's got that down pat. So I imagine we will get there with AI, provided that we don't assume it will solve all known problems right away. So that raises an important issue about timing and about trying new stuff, that if you look at some of the success stories with AI generated code, it's that, hey, we can throw some AI code into this web app and, oh dear, that didn't work too well. Well, live and learn. Tomorrow we'll fix it. The day after we'll have 3 more updates. Next week we'll have version 24 will come out. You don't have that luxury with most embedded devices, do you? Either the older ones cannot update over the air, or there are regulations that prohibit them from updating over the air, or it would just be a terribly bad idea because you can't afford the outage even for something like a reboot because of the real-time nature of it. So how do you balance that? How do you balance the longevity of embedded devices that you wouldn't expect to be using the laptop you have today in 25 years' time? I'm glad I'm not using my 25-year-old laptop, which no longer exists because it didn't last that long. But that's not true with embedded devices. So how do you get AI that's very forward-looking to think about what will be ancient past in the not-too-distant future, if I haven't messed up my words a bit there?
Yeah, I mean, I think it's certainly a challenge. I think. I think in general, what you have to do is just look at general modern day best practices for developing embedded systems. And ultimately, if you're using AI to generate that code, you need to design your systems in such a way that it's scalable, so that it can be broken up into pieces, so that you can
Right.
you can update in the field small pieces of your system, so it's can be compiled separately, it can be deployed separately. In embedded systems, we tend to still generate more monolithic type of systems, at least in the microcontroller space, where you might find you got to flash the entire device. But certainly things are coming
Yes.
along and things are changing. Some of the new parts that are out there are, I mean, I don't look at them almost as resource constrained devices anymore. They are extremely powerful devices, but there's different architectures that you can use in order to try to help solve that problem. And then AI, I found, does have at least a fundamental understanding of software architecture and how to layer things. It makes a lot of mistakes, but again, over time that will improve. And so I think oftentimes if I want to try to design a full thing, one of the things that's in my prompts or in my agent files is that I tell it, hey, this is a resource constrained device. We need to use it for, assume it'll be used in the field for X amount of time. You got to give that background to it so that it kind of understands the context of what's being designed, right? That it is real time, that it's something that's been in the field for a long time. Maybe it needs to be updated. Maybe it needs to scale, maybe it needs to support multiple customers and that sort of thing. But again, today, what I'm seeing is in the embedded systems industry, I'm seeing a lot of people excited about AI, very hesitant to use it. We tend to be late adopters of technologies, let me put it that way, just because of the constraints that we tend to be under. But I may be digressing there a little bit, but
So I guess it's don't throw out the baby with the bathwater, and definitely don't throw out the bath along
Yes.
with the baby and the bathwater. This is a tool that you can bring incrementally into workflows that you've learned and developed and that you can trust. It
Yes.
doesn't. So, in other words, I think what I'm trying to say is you can probably do very well with AI, even in resource constrained embedded spaces, if you treat it as an evolution that helps you do software better or faster or test more or try more options, rather than a revolution that basically lets you press a button and have no human input coding.
Exactly. One of the things that embedded systems developers are traditionally kind of, I'll say, not the greatest at is actually having a lot of unit tests and being really good at testing overall and building that test framework from unit tests, integration tests to full system tests.
Yeah.
And if
Do you
you're
think
using
that's because
AI,
often the systems are monolithic? So you kind of think, well, I can test
yeah,
it all at the end because the
we
app and the operating system are kind of one big lump.
Yeah, we tend to think of it's embedded, and so we tend to want to couple ourselves tightly to the hardware. And so if you're
Yeah.
tightly coupled to the hardware, it becomes a lot harder to unit test things as you try to move up the stack because you have dependencies that, well, I can't test that because it's connected to the hardware. But if
It
you,
becomes a lot harder to adopt the latest generation of that hardware, which may not merely be faster and cheaper. It may actually be significantly safer because it might now have memory protection, or it might have segmentation, or it might have better message passing, or it might have built-in floating point that saves you time that you were wasting before. So it also makes you a
exactly,
bit more future-proof if you do design more layered systems. And AI can
absolutely.
really help with that, can't it? Because while you're thinking of the module you're going to write tomorrow, your AI agents, rather than writing the code, they could simply be beavering away looking for problems in the code that you've had for years.
Oh,
And you may be interested to find things that you simply wouldn't have had the time or the energy or the will to look for otherwise.
yeah. Yeah, you could create an agent that when you check in your code looks for tight coupling between your application code and the low-level drivers and just looks to see if it's abstracted out or not. And, as it runs, it can give out a report that says, yeah, look, this module here is tightly, directly calling into the registers over here. Flag it as a, technical debt to improve because you're tightly coupled there.
So, Joe and Jacob, to finish up, because I'm conscious of time, I'd like to put a question that either or both of you can answer, and that is for engineers, particularly embedded software engineers who want to use AI. Maybe they've only been toying with it so far, or they've been unsure of it because they don't know how they can fit it into their workflow, but they're going to have to cross that bridge sooner or later because someone in their team is going to do it, even if they don't. What things can they start doing right away that will let them enjoy the benefits while dealing with that problem that we mentioned at the start, namely that if AI wrote the code, who bears the risk? How do they keep all of that under control while enjoying the benefits?
You
Yeah,
want to take a
so
shot there?
I think there's a lot of things people can do, and if someone is kind of the edge and wondering if they should start using AI to kind of assist in their code development, I would encourage them to jump in and start doing it. I think you could probably do that in a couple different ways. One way, which is a super powerful tool, although it might be a little scary to people, is OpenClaw, and it becomes a pretty amazing assistant to you, whether that's taking care of daily tasks or even coming up with kind of simple code to incorporate at some point. But more generally, I think getting started in doing it and following kind of the notion of having good guardrails, good practices. You're not changing the way you're testing. You're ensuring you still do all the right testing and compliance items that you would otherwise do for safety critical systems. Then I would start incrementally and see some of the benefits in the return. Of course, you'll always have people like Paul who want to write in assembly itself and may want to do everything by hand. And I'm sure he's 100% correct when he does that, but maybe not. Maybe not even Paul. And
I'm 100% correct 94% of the time.
And yeah, I've always been told that statistics never lie, but liars use statistics. And so with that, no, I would encourage people to get started and certainly be mindful of some of the risks that we talked about today, but don't throw your process out just because you have a great new tool or gadget.
Absolutely.
Jacob, do you want to add to that?
Yeah, I'll maybe just encourage some ideas. First of all, this is a technology that I think is going to, take over the world per se, right? So you can't ignore it. You at least have to be trying to understand what it's capable of, what it can do, where it can make your life safer or your life easier in a safer way, right? As you write your code. And so look at things that are maybe low hanging fruit that you do on a daily basis, things that you could automate and kind of toss over the fence. Like I mentioned earlier, we don't like writing tests a lot as embedded software
Yes.
engineers. Ask AI to make a list of tests that you need for a module that you're going to develop. Ask it to improve your build system, things like that. Things that are very low hanging fruit that may not may not be code generation itself. But eventually, as you move towards using code generation, make sure that you are using static analyzers, dynamic analyzers. When you write code, ask it, hey, how could this be improved for, XYZ vulnerabilities? And, again, don't treat it like it's 100% right, but kind of look and see what it gives you and say, oh, that's interesting. That could be useful. Or sometimes it's just, yeah, no, just move on. But you should at least be exercising the tool and exercising your own critical thinking skills and how do I use this tool? And again, I think it's actually important that we continue to code. I actually have a concern that in the future, we won't know we'll forget how to program, right? Or hopefully programming will become like chess, right? We know that machines are better at chess than we are, but we still enjoy doing it. And so we continue to play chess.
That's
right?
a great analogy because chess has never been more popular than after Deeper Blue proved that computers could always win if they really wanted to. And I guess, the advent of the pocket calculator did not make mathematicians redundant. It didn't make the intellectual exercise of coming up with proofs easier, but it did make doing things like validating proofs, looking for counterexamples, and testing your intuition in ways that you wouldn't have time to do yourself perfectly possible. So that seems like a fantastic place to start if you haven't already. Rather than saying, I'll let the AI do all the things I want to do, how about letting it help you with all the things that you should have done, but technical debt, for want of a better term, has kind of stopped you from doing so? You might be surprised at some of the horrors that you find that you can fix. And that will have improved things greatly, won't it?
Exactly. There's all those things you never had time to do that suddenly, potentially, you now have time to do. So,
yes, no more excuses.
yeah.
Excellent. Gentlemen, thank you so much for your time. It's great to talk to people who are passionate about using new technology in exciting ways, but while keeping the risk tightly under control. So thanks to everybody who tuned in and listened. If you find this podcast insightful, please don't forget to subscribe so you know when each new episode drops. So once again, thanks to everybody who tuned in and listened. And remember, stay ahead of the threat. See you next time.